The High Performance Canada series is brought to you by 475 High Performance Building Supply. This series is also brought to you by Inotech Windows and Doors.
Today on the Build Show, we're in British Columbia's Okanagan region. A few hours off the coast, we're in a completely different climate zone. This house is in a serene setting cut into a hillside surrounded by orchards. I can't wait to go check it out. Let's get going. We're here with Brett from NIDO Designs. Brett, you've been doing passive house and high performance builds in British Columbia for years now. So tell me about this site specifically. Like, what do we have here? What's the climate zone? What's the design constraints? What's going on?
Sure. Well, so to start off, this is climate zone 5.
Okay.
And so just a little bit colder than the coast. Further you get inland, the colder it is. So the further you get away from the ocean, it just gets colder and colder and colder. We have quite extremes, I would say. Could be as low, not very often, but as low as minus 20 degrees Celsius in the wintertime for maybe a week at best kind of thing. But then as high as 37, 38 degrees in the summertime. When we looked at the property, you know, being high performance passive house, you look south and you're like, okay, how can we take advantage of south as best as possible? Because that's where we're going to get all the free energy. But we also had to fit the house into the existing landscape. So that ended up driving the design a little bit more.
Absolutely.
Along with one of the most incredible views out to Okanagan Lake. So this is all east facing. So it's finding that balance point of, okay, how do we still make this high performance, but recognize that the view is not due south?
You guys use a tool called PHPP. Now this is pretty technical stuff. Yeah. So how did you use PHPP for this house specifically to kind of balance that fine line between high performance and budget in terms of like going back and forth with the decisions with the clients?
Sure. So with the PHPP, it's the passive house planning package.
Passive house planning package.
Yeah, and it's just the energy modeling software that we use. You have the ability to define the thermal envelope, define the length of your exterior walls, the size of the roof, the size of the slab, how much insulation you have in all your assemblies. You input all your windows, you select your mechanical system, and ultimately as you work through that entire process, you gain an understanding of how much heating is going to be required on a per meter squared basis. So in passive house, the magic number is 15 kilowatt hours per meter squared a year. What you then do is you determine how much heating is going to be required for that house, and then you can basically tweak and say, okay, if we did this assembly here, that brings that heating demand down by X. If we change the windows from this brand or this model, that improves it here. If we change even just the glass, that makes differences. Or
the interesting tweak that I see here right off the bat, you're not utilizing exterior insulation on this project. So it came to our attention after filming this episode that there could have been some potential issues with that diagonal rain screen cavity. Now, we're going to hop on a Zoom call with Brett and Andrew to really figure out what's going on.
The part I found interesting, Andrew, was like the building code. The building code wording is like, when I talk to an official about this, it really comes down to the official having jurisdiction, because you've seen it before. Diagonal strapping is something that's actually quite common, and building official interpretation is really what it comes down to for that vertical versus diagonal in the building code.
Yep, exactly. And I think there's also, one of the comments was, well, it would have passed inspection. Is that what's really important? Like, would it pass inspection, or even is it meeting code? Code is certainly necessary, but the worst we can build a home by law. So maybe that's not our standard of practice. So yeah, maybe it would have passed because we're not required to have that here. It would have passed inspection. But the point was that once we knew there was a risk, we had a duty to mitigate that risk.
So with the diagonal cladding, what the risk was there was that there were numerous cavities that had minimal amounts of ventilation. So that's the major risk that was presented. So where the misconception of why rain screens are required, most think it's just to have drying behind the cladding, but it's actually twofold. It's drying behind the cladding, but it's also to allow outward vapor drive from thick wall assemblies. Any moisture that gets within that thick wall assembly, it has the ability to dry within that ventilation cavity and then out and exhaust out. So it protects the cladding, but it also protects the wall assembly.
We went with a 1/2 inch vertical on the wall, and then we actually went with a 3/4 inch by 1 3/4 on the horizontal. Part of the root of why we made the decision to redo everything as well is that there's a bit of a responsibility that if you're sort of advertising something that could potentially cause a risk in this climate zone, another climate zone, or different factors may or may not be better or worse. But part of the issue is that somebody might jump on here and say, oh, that's a great idea. I'm just going to put 2x12 walls in there and stuff them full of insulation, or I'm going to do this detail that I saw, somewhere. And if they don't have a proper understanding of the risks that are involved, well, then do we have a responsibility to be, educating as well as just, sort of highlighting what we're doing so that there's a better understanding of what risks are involved.
But it's so important to understand and just throw your blinders out the window. You can't just look at one specific thing in a video and say, I'm going to apply that to my job without understanding the ramifications of, other things that it can affect. You guys are pros for, catching this issue, first of all, but really understanding it and making sure that you're doing the right thing.
You're not utilizing exterior insulation on this project, right?
That's right, yeah.
So you're building that thermal bridging into your energy model, and still able to get a thermally efficient envelope, despite having the studs not protected by a blanket of insulation.
It was a trade-off, and this is more, it's partly informed by that energy model, but it's also just partly informed by experience. And we know from experience that there are advantages to having that exterior insulation. But there's also advantages to just having a really, really thick wall. And so if we were to compare like a 2x6 wall with sheathing and 3 inches of mineral wool versus what this is basically, it's just 2x12 framing. But the studs actually, it's 2x12s at the rough openings, 2x6s back to back.
Okay.
That's actually a higher performing wall assembly than a 2x6 with 3 inches of exterior insulation. There's advantages to mineral wool or foam or wood fiberboard on the exterior, but in terms of just actual performance and construction cost to build, this is a less expensive wall to construct.
I think it's really interesting the fact that you guys weren't afraid to eliminate that exterior insulation and just value engineer that wall. And that's what that PHPP allows you to do. And then of course, a mixture of that and experience of knowing what's buildable, what's inexpensive in terms of the thermal efficiency, right?
Yeah.
This is the covered outdoor kitchen? Or we have a living space here?
It's just just a covered outdoor patio. They'll have the barbecue back here, but it's really just covered space to enjoy this.
What a spot to have dinner, have a glass of wine. I wanna ask you about how you guys, so this is your thermal envelope. Is this beam coming through your envelope, looks like?
That is, yes, you found the two thermal bridges in the entire, now there's actually three. So we've got a thermal bridge there with that structural beam, a thermal bridge there with that structural beam, but pretty small in that it's wood, it's not steel. So that was taken into account in the energy model. The remaining thermal bridge was that we did a traditional strip footing and foundation wall. The foundation wall was constructed with an ICF, but we didn't actually completely encapsulate the footing.
So you have a little bit of cold coming up that from the footing.
Yeah.
So we're at the back of the house, and I want to ask you about the lack of overhangs. I love the style, trust me, and I've been talking to people about lack of overhangs, and a lot of people will steer you away from it. I know it's a tool in it's a tool in Passive House to have overhangs, right? So that's part of your PHPP modeling, not having much shade for these windows. I know your windows are pushed back, but I really want to talk to you about the waterproofing of the lack of, when you don't have overhangs, and also the wood siding protection. So
Sure.
It's brave, but I want to see how you're addressing it here. So
Sure.
what do you have up kind of that transition?
So at the transition, this is a vented truss. In behind this gutter, we actually have a intermittent blocking, which allows for airflow to get up into that truss space. And then the roof membrane, you can't really see it, but it comes right over top of that. And then it also then comes right into that gutter. And in behind that, in our detailing, we even have peel and stick that goes over top of the subfascia.
Okay.
So any water, it's always going to come over top of that
So you
exterior
have
cladding.
kind of a double waterproofing layer where you probably waterproofed the WRB up to the roofing membrane first.
Yeah.
And when I drove up, I saw that the gutters are installed already. Usually, it's the last thing you do on a house.
Yeah.
So you're actually incorporating this European-style gutter into a second layer of waterproofing, right?
That's right. In the membranes that we're doing on the interior as well, they're going to be we'll be shooting for 0.06 Passive House levels of air tightness. And then on top of that are 24 inches of insulation from eave right up to ridge. So whereas again on kind of conventional older buildings, that insulation at that eave could have been squeezed down to 3-4 inches.
Okay.
The other advantage that we have here in the Okanagan is we do have rain, but we don't have the rain that the coast has.
Yes.
So it's a little, I don't know if we would do a roof without eaves on the coast like we did here, but here it's a little less risky.
So we're here with Andrew from Red Stag Contracting. He's the builder on this job. He's been building in the Okanagan for several years now. So Andrew, let's go in and have a look at what you got going on. So how many bedrooms do we have?
3 bedrooms. So there's 2 bedrooms on the west side of the home, and then master bedroom ensuite on this side. Obviously, take advantage of the great view that we
Master
got here.
bedroom gets the views.
Yep.
Yeah. So the home vault's here, and then
Yep.
back there you have more a flat traditional truss system back in this section where you enter.
That's right. So basically 9-foot ceilings to the bedrooms, office, den, laundry area of the home, all the living and kitchen out here in the vault. And there's a loft up there, future loft for basically for their kids.
Little hangout spot?
Little hangout spot, some cargo netting for guardrail, and this bay actually right here will receive some millwork that doubles as a ladder to access that area. Yeah.
That's so cool. That's very fun. And so like from a design perspective, this like the compartmentalization of the home is really simple. You have this volume that stretches out this way with a scissor truss, and then you have the back section, bedrooms, bathrooms, utility, everything, and then you have more opportunity to run services in those trusses. We're in the entranceway here, and this section of the truss system has been basically raised up that all your services are running through here. Yeah.
Exactly. Yeah. So you can see insulated and non-insulated ducts here for the ERV, HRV.
Yeah.
That's supplying hot and cold air to the bedrooms, pulling from the bathrooms, high humidity areas, and we're able to run that in our warm space without having to go in and out of the vapor barrier.
Yeah.
That lends itself to more air tightness.
So airtight OSB, all taped.
Yes.
Probably right away when you framed it.
Yep.
Right.
Yeah.
So it was just ready to go for all your services.
That's
and
right.
then you have kind of a corridor here, and this. This is such a cool idea to have that. So was there a decision behind putting the mechanical closet specifically here? Or?
Yeah, it was all driven basically by. It was all driven by basically the design of the ducting for the HRV. So NIDO Design actually provided us with the initial layout of that, and it's basically kind of a centralized hub. So pretty challenging in that we have a fairly small mechanical room.
Okay.
There's a lot of equipment to go in here. But
really nice birch plywood you got up there right away.
Yeah, that's our
Awesome.
our standard mechanical room detail. Either this or a dark stained black, but this provides a lot more light, obviously. So, obviously, great work by my plumber, setting the tone for the rest of the trades coming in behind him.
Yeah.
Everything's well labeled for the homeowner should they need to do any quick shutoffs.
Yeah, everything right there.
Electrical panel here. We've roughed in for solar. That may happen before the end of the project. We're not quite sure yet.
Okay. That's a requirement here, right?
It's not yet.
Okay.
In fact, actually, Summerland municipality hasn't adopted any step code yet.
Okay.
Us, along with a few other builders, are definitely pushing them to adopt
Absolutely.
a higher level. But at this time, no, it's not a requirement. For
So you're not only a step above in step code. You get this building, I understand, is step 4 on the step code, but you're also not required to be even step 3.
Not even step 2.
Not even step 2 in this area.
Yeah.
Okay.
And then the ERV here, which is basically, it's a Canadian-made product out of Quebec. And this is the little magic box. So it's an ERV with a heat pump built into it. So the cooling capacity is enough for the losses on this house. And the heating is supplemented slightly by some radiant panels and a few electric coil in-floor heat in our large window openings here.
So the heat pump is still outside though, right?
The heat pump's built into here.
Built-in
actually.
heat pump.
It's built into here.
Wow.
And it has a post unit electric coil heater that's hung just up here. So on the really cold days of year when this a heat pump tends to not function really well at -10, -15, that electric coil heat can kick in and still provide enough heat to the rest of the house.
Did that coil come with this unit?
It does. It's all part and parcel. So
This must be super efficient then.
very, very efficient product. Yeah. So only works if you have a very tight envelope and the right insulation details, which NIDO was able to provide and design around this house. So not for every home, but here it works. Yeah. One of the things that came again as a function about costing and constructability, and it just happens to lend itself to better performance, was anywhere in the field where we were able to eliminate a full 2x12 stud and go to a double 2x6 stud. There's a 1/4 inch gap on average between them.
Okay.
We've cut cleats here just for keeping the wall nice and straight. But this was basically a function of pricing.
Okay.
2x6 is quite a bit less expensive than a single 2x12.
And so when you say when you were able to, is that because of a certain, like why would you put a 2x12 here?
This one happens to be because of a splice in the top plate, so we wanted to get full nailing on there. And then obviously at our window openings, door openings, corners, we've gone with solid material.
Interesting for your lumber takeoffs.
It is very
super organized.
It is, yes. And 2x12, good 2x12 material is also hard to come by, especially here. The coast, there's quite a bit more supply. So this package actually came out of the coast. We were able to get better pricing on it and more consistent materials.
Yeah, so about R34 walls you guys have here?
Yeah, exactly.
Effective R34.
That's right, yeah.
After all the glazing and thermal bridging, still at R34.
Yep.
And about an R70 roof effective.
That's right, yeah. Part of what comes with higher end or higher efficiency homes is trying to design, we sort of ask people what's the smallest amount of space you can live in happily rather than how much can you build for your budget.
Yeah.
So this is a small home by today's standards, netting at 2,200 finished square feet.
2,200 square feet.
Yeah.
To me, that's perfect.
Exactly, yeah. So it can also be challenging to create a big feel and fit everything in here that you want without growing more and more square footage. So I think the design's done that very well. It's certainly a large enough master for a couple. Fantastic view out of their soaker bathtub.
Wow.
Yeah, and I mean, all the views from every room basically is pretty incredible. One of the notes with high performance building that doesn't get discussed a lot too is that if we sort of trace people's interactions within a home, it's very often that older homes or code built minimum homes, there's not a lot of traffic around the exterior of the building, especially near large openings because of the cold feel or possibly drafty windows, that sort of thing. In a high performance building, you have full comfort, right to the edge of your living space. So
Interesting.
It tends to feel bigger because you're not hemmed in by the feeling of a drafty space or cold wall sections, cold windows, that sort of thing. So
I grew up in a really cold and air leaky house.
Exactly, yeah.
And we would go upstairs, sleep in the bedrooms, and then in the wintertime, we would shut all the doors upstairs, and no one would use the upstairs of the house because it's too cold. Or in the summer, it was way too hot.
Way too hot,
And we'd always just converge around, of course, the most comfortable areas of the home.
That's right, yeah.
And those rooms really wouldn't get used unless you just went up there to sleep and you had a heater on, right? In the bedroom.
So designing around, even heating and cooling distribution and full comfort, everywhere in the home, that's really important. And it also, the function of that creates a healthy home as well. So, I mean, that's sort of what we're pushing more than just the energy efficiency. The efficiency just happens to be a byproduct of wanting to create that space for families. Yeah.
Is that something that you're finding in this area clients are demanding more, or are you educating clients on high performance buildings?
I'd say it's definitely a mix. Like initially it was definitely came from us as an education standpoint, trying to, and we found that once clients learned a little bit about it, they were pretty keen, gung-ho to do that.
Yeah.
But now we're finding it's about 50-50. Some people are unaware of BC step code or what's available to them, and other people come to us seeking a step 4, or maybe even their questions about passive home, that type of thing.
Thanks for showing us around today.
Yeah, you're welcome.
Really great, and maybe I can come and do another tour when it's done.
Absolutely, yeah.
Almost done.
Yeah.
I know I love this design aesthetic. I can kind of picture it. I haven't even seen the interior design drawings, but I can kind of picture it.
I think
and
pretty incredible. Yeah, we'd like to see you guys back here.
Once the kitchen's back in, this is going to be a stunning spot.
Absolutely, yeah.
Right. All right, appreciate it.
Okay, thanks guys.
I got to be honest, I'm completely blown away by this project. What really needs to be highlighted here is the simplistic approach to energy efficiency and design. NIDO Designs, the architect, and Red Stag Contracting did a fabulous job here of just incorporating, you know, off-the-shelf building materials and really smart details to just overall give these clients a simple, beautiful, and efficient home. So they should be applauded for that. Thanks very much for tuning in. We'll see you guys on the next one.